Lesson 1-6 Geometry. Today's date is Friday, September 4th, 9/4/2020. I said this in all my other videos, but my God, it is so nice using an Apple Pencil. It's like, yeah, miles and miles better than just the styles I was using before. Yeah, so reflections, 1-6. Our objective today is to do what? Esha.
Perform and determine reflections across horizontal and vertical lines.
There it is. And notice that you don't have to reflect over diagonal lines like this. It's either going to be your vertical or it's going to be horizontal. No diagonals yet. You will be doing that later. Okay, yeah, so let's just go over some general properties. The distance from the source, again, that's your starting image or your starting point or shape, to the line of reflection. You're always reflecting over line, is, and then you want to take a guess at this? Yeah, Hazi?
The same.
The same, yeah. So I'll come down here, say the same. Is the same as the distance between the image and the line of reflection. And in geometry, I'm going to go ahead and get that formal word on here. I should have been using the word congruent. I'll write that up above here if I can zoom in here. This should be congruent. That should be the word that we should start using, but for now we'll say that's the same, but the distance is congruent to the distance between those other, the image and the source. All right, 2, the line segment from the source to the image is, and you want to be thinking about this, so if I have some sort of line of reflection and then I'm going from this, from the source, this point is the source, and I'm going this way towards the image, which is reflected over here. This angle right here that I'm asking for is, what?
90 degrees.
90 degrees, yep. And do you know the name for 90 degrees? It starts with a P.
What?
The name for 90 degrees, it starts with a P. Yes, I heard it just barely. Perpendicular, yep. And I'll also write down why it's 90 degrees. Same thing, 90 degrees perpendicular to the line of reflection. And you'll see these in a sec once we do this example. So zoom out a little bit. We're on to example number 1. Plot the image of the point A under reflection across the y-axis. So A is our source, you can see right over here, and then we're going to reflect it over the y-axis. So first of all, remember that the y-axis is labeled up here, that's the y-axis. So I'm reflecting over this line. I'm going to be jumping and jumping somewhere over there. Can someone tell me the coordinates of A prime after I apply this transformation? There's only 3 people that got this one already. Ulysses?
Would it be 3, 4?
3, 4, yep. So come up here to 3, 4, and this is A prime, which is 3, 4. Nice. Notice that A started at -3, 4, which is kind of interesting. So you always want to be thinking, how would I do this without a graph? Because the graph is kind of the prop right now. If I have a reflection over the y-axis, it's the x number that got changed, so it's the opposite of the x, which is kind of interesting, right? They're opposites of each other. Okay, and then finally, plot the image of point B under reflection over the x-axis. So who's got the coordinates of B prime? Starting here, reflecting over the x-axis. Kira.
Would it be -2 or 1, -2?
1, -2 right here. Yep, so there's our B prime. Again, take a look at those coordinates because it's kind of interesting what's going on here. So B originally started at 1, 2, and then B prime, as Kira correctly said, is 1, -2. And again, it's weird that the reflecting over the x-axis is going to make the opposite of the y's. It was 2 and then it turned into a -2. Went back too far. Question. Yeah, Esha. Oh, I should stop clicking on unmute. Sorry, go for it.
That's okay. Well, I want to clarify something. That is it. So B You do not reflect over the y-axis, only the x-axis, and A, you do not reflect over the x-axis, only the y-axis.
Yeah, I'm just doing what it tells me. If it told me A over the x-axis, I would have done over the x-axis. It's whatever it says right here.
Oh, okay. Now that makes way more sense.
Yep. All right, moving on to reflecting. Let's find this pattern, right? I told you guys to pay attention because eventually they're going to be asking these things without a graph. So if I'm reflecting over just the x-axis, so that's very similar to B up here. X, Y will do what? I'm going to have some new coordinates over here and a comma. Does the X change or does the Y change? And how? Give you guys time to think about this because this is kind of the deepest thinking that we're going to be doing today. So I want to give the proper amount of consideration. Again, if I'm reflecting over the x-axis, what is changing? Is it the X or the Y, and how? Do I add 2 to it? Do I multiply by -1? Do I divide it by 2? What's going on? I see 2 hands, but I'm going to wait for more hands. I see Ulysses and Charles. What's happening here? Let's go with Ulysses.
It'd be the Y changing.
The Y is the
And
one that changes, yeah. Oh, sorry, I cut you off. And you said negative?
Yeah.
Yep, so the X stays the same, so just rewrite the X. X does not change, but the Y does. It's now a negative Y. And that's our rule. Like, this is the rule that is given to you in textbooks, but you guys have derived this yourself, which is more awesome. So as our example, if I started with 4, 5, I'm reflecting over the X axis, this will turn into what? Nice and quick. Who's got it first? Sorry, Ulysses, I want to call someone new. Jade, yeah.
4, -5.
4, -5, there it is. Okay, and then very similar, reflecting over the y-axis, what's our rule? I'm hoping I can get at least 4 hands. I'm not moving until I get 4 hands. I got 1 hand, 2 hands, Charles, Esha, Wyatt. I got 3 hands. There's 4 hands, go with Esha.
Well, it would be -xy, which
There it is.
x, y.
And Ugo, tell me this one. 4, 5 turns into?
-4, 5.
It is -4, 5. It's a bad 5, I can try again.
So this is pretty much what we're going to be doing for the homework.
Very, very similar, yep. But sometimes we just have a line that's not an X or a Y axis. There's always this trick if you're doing X or Y axis, but sometimes it's just a line. There's no X or Y axis to relate to. No, I went back too far. So how do I reflect this one? And this one is just purely distance, right? I'm going to count the number of squares. I have 1, 2, 3, 4, and then I have to count the same number of squares. 1, 2, 3, 4. So there's no way that you can, I mean, if I was doing this in class, I would have someone come up and write this on the board, but just count the squares here. So this is going to be C prime. Just note that this distance, I can say this distance is equal to this distance. These two distances are the same. So I'll say, maybe in a different color. Same distance here and here. It's one of those preserving distance type of transformations. All right, and most of them are. They're all rigid transformations except for dilations. Raise your hand if you want some more time to copy some stuff down. Okay, I see 2 hands. For those 2 people, just let me know when you're ready to go move on with a thumbs up. Okay, so The line of reflection is always the what of the source in the image. And you want to be thinking, if I have some sort of drawing, I don't know, of a point here, and I have a point here, and I know that these 2 points, maybe the first one was a source and the second one was the image. I'm trying to find the line of reflection now. Where do I put it? Do I put it here? Do I put it there? Do I put it there? Like, where does that line of reflection go? That's the question that I have for you guys. How do you say that? Charles?
Like the middle, like perfectly in between the
Yeah.
two. Like it's the same distance away from the source and the image.
Oh yeah, that second one was getting really close to the word that I want to use. So
Yeah, I know. I can't figure out what the word is.
let's say middle for now, and then again, this is like the transition period of we are getting more and more advanced with our language, and it is the meaning of this word is same distance. Does anyone remember what that word is? Looks like Wyatt knows. Does anyone else know? Same distance. Go for it, Wyatt.
Is it the median?
Not quite. So median is more of a statistic word. Median can be, it is a geometry term too, but it's not the right one. It's equidistant. It's an equal distance between the two. So you can say if I have my line of reflection, this line of reflection is equidistant to the source and the image. And that's what I meant like back here on the bottom of this, like these two distances are the same, they are equidistant from each other. Okay, so we have 2 examples. First, we need to find the line of reflection, and eventually we're going to be doing construction using compass and straight edge, but that is much more efficient when you guys are back in school. So I'm hoping that we stay back in school for a little bit of time so we can do some constructions. But for now, we can just find the midpoint or the equidistant line. So how do I find the halfway point between A and A prime, or between B and B prime? It's kind of the question, I guess, or between C and C prime. You can choose any 2 points that you want to find the first point that's on the line, right? Anyone have an idea? How are we going to find the line of reflection here? You can eyeball it and get it pretty darn close. I've heard from a lot of these people already multiple times, although Ash has only done 1 math problem. Let's go with Ash again. Now you've done 2 after this.
Well, you could just count from, okay, so from A to A prime, it's 6 spaces. So in the 3rd space, you can put a dot and draw a line, and you possibly, is that what you do?
I mean, that's definitely this point that you've drawn right here is going to be a point that is on that line of reflection. But then you told me to draw a line, and I don't know, there's a lot of lines I can draw through that point. So I'm not sure what you meant by.
Draw a line, gosh, I always get them mixed up. Draw a horizontal line.
Horizontal line like that?
Yeah.
Okay, yeah, and that is the answer. And because I've restricted this lesson to only horizontal and vertical lines, you have a 50-50 shot of getting it correct. But let's say, what if it could have been a diagonal line? How do we verify that? You can verify that by doing another counting, right? You can say, okay, between B and B prime, let's count the spots. 1, 2, 3, 4, 5, 6, 7, 8. Take half of that, 4, count down 4. So 1, 2, 3, 4, right there. And then 2 points always makes a line. You can make a line through those 2 points. Shoink, and lo and behold, it is indeed a horizontal line. And again, if I did it between C and C prime, I should have gotten a point right there. And you don't need that 3rd point, but 2 points makes a line, and there's your line of reflection. Cool. Questions? So we should probably list our steps just in case you get mixed up. So our first step was to find the distance between source, can't spell source, and image. And then we found that was 6 in our first case, right? So I'll put a 6 in parentheses. And then step number 2 was we took half of that distance. And then I'll say, move half distance. In this case was 3. And then you're basically done at that point. You can either choose a horizontal or vertical line because it's this lesson. But for future lessons, step 3, repeat for another set of source and image. Like we did, we started with A and A prime, that was step 1 and 2. And then we did B and B prime, that's step 3. And yes, if I were being very technical about this, which we need to be in geometry, we're gonna connect those 2 points with a line. I cannot spell connect. Connect points from step 2 and step 3 with a line. And that line is the line of reflection. And because this is that intro lesson to reflections, they're not gonna do anything weird like the line of reflection is at a half or at a third or something like that. It'll be a whole integer number. It'll be nice. Cool, so you guys now should be able to do this one on your own. Example number 4. Oh, scroll up just in case you didn't copy all those steps down. Try to do example 4 on your own now. You have the steps, you have an example. This one is slightly harder. This is about as hard as I can make it up to this lesson. Try to find the line of reflection that reflects triangle XYZ onto triangle X prime, Y prime, Z prime. Is it a question, Hazi? Or sorry, not Hazi. Ulysses, or is it an answer?
It's an answer.
Oh, you already got it? Okay, well, I need to I need to give everyone else some waiting time. You're too fast. You went ahead of us. But that's awesome. If you already have it, maybe you can, I can do breakout rooms. You can check it with someone, or that's probably the easiest way to do it. I'm gonna do breakout rooms. You guys can check with a partner, and then once you're done with that, come back into my room. You'll turn your cameras off, and then you can do homework. But for now, breakout rooms.
Wait, can you scroll down, Mr. Sindel, please?
Oh, yeah, you might want to see all of example 4.
Mr. Sindel, I need to finish writing the notes too.
Best of both worlds. So if you're sitting there twiddling your thumbs, make sure that you're not doing that. Go to the homework, start on it early. We'll come back and check example 4 in a few seconds.
What if you did that and you're still...
Okay, so how do I do example 4 now? Ulysses has been waiting forever. Yeah, I'm gonna give it to you.
Like I found like y. I did y and y prime, and I found like in the middle of that, and it's 2, -4, and so I just drew a line across the x-axis.
A line across the x-axis.
From the point.
Oh, on the point. So parallel to the x-axis through that point. So a horizontal line through that point. Yep.
Yeah.
There's a correct answer. And again, you could have checked that. You could find the distance between z and 0 prime, which is 4. Half that distance is 2. And therefore, we have coordinates -4, -4. Same thing between x and x prime. I could have found the halfway point, the equidistant point, which is -2, -4. Cool. And there's our answer for example 4. I don't want to keep you guys late. That's all we have.